Triple chemistry, reversible reactions and industrial processes. The first question is a nice long 6 marker. It gives you the setup of the Haber process, the conditions of the Haber process, atmospheres and pressures. Explain your choice of temperature and pressure used and explain why it's necessary to use the reaction. Okay, so it is a reversible reaction, so it can go either way. Higher yield will happen if there's low temperature. However, low temperature means low rate. Okay, so high yield if there's high pressure, however it costs more, so it's more hazardous. The temperature and the pressure are compromises to ensure high yield but low running costs. Catalysts added to speed up the rate of reaction by lowering activation energy without being used up. The second question then, it says using the left-hand side, so the left-hand side by here, number of nitrogen atoms, so you've got 2. Mistake people will make now is it's 3 times 2 will give you 6. Give the meaning of the G in the equation, that's gas. Okay, so if it was an S, it'd be solid. If it was an L, it'd be liquid. Choose from the process used to remove the product of the reaction mixture. Remember, it is condensed in a condenser, so it's cooled because there's no condense there. The method used to reduce waste of the reactants, they are then recycled, and you can look at this one, I know it won't be there on the day, but they are then recycled back to the beginning, and you can make more ammonia. Choose from the box above, using the reaction, state the purpose of this catalyst. So it has to be iron because these two are actually used in the reaction, so they can't be catalysts. And that one is as well. The rest of them aren't metals or catalysts. So iron, speed up the rate of reaction. You should really write with that below there without being used up. Question number 3 then, very similar to question number 2. Name the gas formed from natural gas, so it's hydrogen because you need nitrogen and hydrogen to make ammonia. Give the name of the catalyst and state why it's used. Iron, speed up the rate of reaction without being used up itself, lowers activation energy. The yield of ammonia is only 28%, therefore 72% of the gases remain unreacted. Describe what happens to these unreacted gases and state why it's important. It's this bit here at the bottom in the pink, they actually go over there. So it's recycled into the reactor, reduces cost and less waste. So what happens is any that isn't used, the unreacted gases, go back to the beginning because it's a reversible reaction and start again. Okay. Describe how the yield of ammonia varies with temperature. And as you can see here, lower yield with higher temperature, you can get that from the graph. Higher yield with high pressure, again, you can get that from the graph. Okay, so you can see that they're higher yields here. Final bit then, write a balanced symbol equation. So nitrogen is a diatomic molecule, so is hydrogen, and they make NH3, and then you have to have a good balance in it. It's 1 mark for putting out the reactants, the products, 1 mark for balance. Name the raw material that provides oxygen in stage 1, that's the air. Describe the last 2 stages of the contact process, stage 3 and 4. Dissolve sulfur trioxide with H2SO4, so sulfuric acid. Okay, that makes the oleum. Then stage 4, dilute with water to produce H2SO4. So put a bit there. Okay, so it produces the oleum. Name the catalyst used in stage 2. So this process uses a vanadium catalyst, vanadium 5. In terms of the elements present, sugar, describe what happens during this reaction. Acid dehydrates the sugar, removing the water, and the carbon remains. That's what that solid black is. Write a balanced symbol equation to represent this reaction. It kind of gives you the help here though. So sulfur dioxide and oxygen to form sulfur trioxide. So dioxide, 2 oxygens, oxygens diatomic, so exist as a pair, trioxide. So it was 1 mark for that, 1 mark for that, and then a final mark for balancing. Okay, and you could have used quite a lot of the information at the top there. Use the graph to find the increase in percentage yield if the temperature is reduced from 650 to 450. Okay, so I found both values, found 650, which is 56, found 450 and took them away from each other, so 30% percentage increase. 1 molecule of sulfur trioxide reacts with 1 molecule of sulfuric acid. 1 molecule of oleum is found as the only product. Write the balanced symbol equation. Exactly the same thing again. Sulfur trioxide is going to have 3 oxygens. You have to learn that sulfuric acid is H2SO4, and then you could have kind of worked out what it was then. The final bit of this question, state what you would observe when a few drops of concentrated sulfuric acid are added to a beaker containing a small amount of sugar. Name the products left in the beaker. So you'd see a black solid form, water, vapour and steam would be given off. Carbon, that black carbon is made and it would have a smell. Question 6, you can see all these questions about the industrial processes follow quite a similar process. Again, a flow diagram. Give the name of element A, so it's sulfur. Catalyst B, you've got to learn the catalyst for both the contact process, which is this, and the Haber process, which is the one that makes ammonia. And then the acid that's made is H2SO4, so sulfuric acid. Write a balanced symbol equation for the formation of sulfur trioxide in stage 2. So you've got sulfur dioxide is burnt in air, so sulfur dioxide burnt in air, so air contains oxygen, so you make sulfur trioxide. Okay, again 3 marks, 1 mark for reactants, 1 mark for products, final mark for balancing. Give a few drops of concentrated sulfuric acid were added to some crystals of hydrated copper sulfate, and there's the formula for it. Describe 2 changes in appearance of the copper sulfate as it dehydrates. Copper sulfate turns white, loses crystal appearance, it becomes quite powdery. So, I think nearly there at the end. Okay, question number 7 is looking at fertilisers. Describe the benefits and problems with nitrous fertilisers. So this question does come up. You need to know a couple of benefits and problems. So benefits: increased crop yield means we make more food, the plants are healthier, and 9 times out of 10 we end up with cheaper food. Problems: so that makes the soil acidic, pollutes water supply, and then eutrophication. Obviously this is a 6-mark question, so I'd be expecting you on the day to expand it into longer answers. Again, the same kind of setup. The flow diagram below outlines the manufacture of ammonia by the Haber process. Exactly the same things we've done before. Name 2 raw materials used in the Haber process. So air and natural gas. You could have written nitrogen and hydrogen there. Balance the symbol equation. We've done loads of balancing. State why iron is added in stage 1. It's a catalyst, lowers activation energy. Give 1 reason why gases are cooled in stage 2 to remove and get ammonia. Okay, so it's currently a gas. You want to cool it to a liquid. Suggest a reason why recycling untreated nitrogen and hydrogen save money. No waste, you can reuse it. Okay, last little bit then. Give one of the uses of ammonia in the production of nitrous fertilisers. It makes ammonium nitrate, which is a fertiliser. And then last bit then, a nice box, and you've got to benefit to farmers. One of these would be increased crop yield. Problems with farmers, increased soil acidity.